Let's talk about question 8, which tells us that we're currently in an airplane company and we're trying to design a metric such that we can try to cue how early the plane should be repaired based on their profiles. So this profile will be expressed as a two-dimensional column vector. And our current metrics for part A will be the one that's used by Airbus, which will be this inner product definition, such that the inner product of x and y is equal to x transpose times this matrix M, which has the components here, times y. So if two profiles are here, which one should we fix first? Should we fix the plane with profile V1 first or the one with V2 first? So in other words, we're trying to see which plane has the larger norm squared. And let us remind ourselves that the inner product of a vector with itself is directly equal to the norm of a vector itself squared. So now let's try to calculate the norm squared of each profile so we know which one has a larger norm squared and therefore which plane needs to be repaired first. For the first profile, we will have to write out a matrix computation to the lines of this. Okay, so I will try to multiply the matrices together, and then in the end, I'll reach an algebraic expression that is something like this. So I have 100 30 times 30 plus 1/10 times 3 times 30 plus 1/10 times 3 times 30 plus 2 times 3 times 3. And in the end, this is about equal to 9 plus 9 plus 9 plus 18, which is equal to 45. Now I have to deal with the second profile's norm square, which will still take this form of computation, except the numbers change a little. So I'm still going to write out the matrix notations. And know that this is equal to 100 times 20 times 20. Again, this is just some algebraic step. And you can reach here by doing regular matrix multiplication as well. And last I have plus 2 times 10 times 10. So this gives us a value that's something like 4 plus 20 plus 20 plus 200, which is 244. And since the second profile's norm squared is larger than the first profile's norm squared, plane 2 should be fixed first, because it has a larger priority. Now that we have first finished dealing with the first part of the question, let's move on to the other part. So now we decided to take inspiration from the previous definition of inner product and create our own, which is that in the equation, the matrix M here is being replaced by some other matrix that is a diagonal matrix, and we don't know the elements along the diagonal yet. But we have to calculate that such that for a profile X and profile Y like this, the norm squared of X is equal to the norm squared of Y, which is equal to 5. So in order to know the unknown components A1 and A2, we will indeed have to calculate the norm squared of each profile again. So this time the computation will look something like this. It will look very similar to what we did in part 1, except the matrix A changes and the profile we're working with is different. And this ends up being A1 times 100, which is 10 squared, plus A2 times 2 squared. And again, this is just some algebraic step, and this is equal to 5. I have another profile that I have to deal with, and this time is 21 times A1 0 0 A2 times 21, and this time is not in transpose. And so I reached that this is also equal to A1 times 20 squared plus A2 times 1 squared this time, and then this is equal to 5. So in other words, we reached this system of two equations with two unknowns such that 100A1 plus 4A2 is equal to 5, while 400A1 plus A2 is also equal to 5. So I can either build a matrix vector multiplication system with this, or I can just directly start solving it. And the way I'll do that is multiply the first equation by 4, so I can subtract these two equations and get rid of the A1 term. Or actually, since I multiplied by 4, this should be 20 instead. Okay, I'm going to subtract these equations. And I'll get that 15a2 is equal to 15, so a2 is equal to 1. Now that I know that a2 is equal to 1, what I can do is plug a2 is equal to 1 to the previous equation, so 100a1 plus 4 times 1 is equal to 5, which tells me that 100a1 is equal to 1, and thus a1 is equal to 1 over 100. So in the end, we reach the conclusion that the unknown components along the diagonals of a, which is a1 and a2, is respectively that a1 is equal to 1 over 100 and a2 is equal to 1. And so we have solved this problem.